All right, in this video here, we're going to look at some examples of compositions of functions. Now, I did another video where I talked about like the definition of a composition of functions and an explanation of what it means, and I did an example in that video as well. So if you're looking for that, you can check out that video. In this one, I'm just going to go ahead and do some examples where we put together compositions of functions. All right, so for this first example, these first few examples, our two functions are f of x equals the square root of x and f of x equals the square root of 2 minus x. Right, so those are the two functions, and I'm going to put together four different compositions. So the first one is going to be f of g. Right, so when I'm doing a composition of functions, remember what that means is that the second function I have here, the g function, is going to be the input to that first function, f. Right, so f of g means f of g of x. Right, the g of x is the input into the f function. Right, so my g function is that square root of 2 minus x. Right, so it's going to be the f of the square root of 2 minus x. All right, so that's what I have to do. So now that entire g function becomes the input into this f function. And the f function says whatever's in that parentheses, I put it underneath the square root symbol. So this is going to be the square root of 2 minus x. All right, so I got a square root inside of a square root here. Right, so hope that makes sense. When we're doing a composition of functions, the g function here, the square root of 2 minus x, I put that into the f function. Wherever that x is, I put this entire function. So it's the square root of this entire function, the square root of 2 minus x. Right? Composition of functions is combining two different functions together, one of them being the input to the other one. All right, so this entire function goes in place of the x here, and this is what we get. Now, can we combine that function? Can we simplify that somehow? We can, right? The square root of the square root is actually the fourth root. All right, so this is equal to the fourth root of 2 minus x. Right? And if you don't believe me that that's the case, it's a little weird. You don't usually see square roots within square roots, but a way you can do this is, remember, the square root corresponds to the 1/2 power. If you remember the rules of exponents and how those relate to roots. So this square root of the square root of 2 minus x, well, the square root of 2 minus x is 2 minus x to the 1/2 power. And if I do the square root of all that, then that's also raised to the 1/2 power. All right, so, and then if I use the rules of exponents, a power to a power I multiply, 1/2 times 1/2 is 1/4, and the 1/4 power corresponds to the fourth root, and so I get the fourth root of 2 minus x. All right, so that's what I get for f of g. All right, f of g is equal to the fourth root of 2 minus x. All right, and unfortunately I'm going to have to erase that so that I can do these other ones up here. But I'll just maybe put the answer to that up here so we can hold on to it and see what it looks like and compare it to the other ones that we get. All right, so f of g is the fourth root of 2 minus x. All right, so the next one now we're going to do g of f. All right, so same two functions, but now that I'm doing the composition in a different order, I am going to get a different result. Right? Composition of functions is not commutative. If you switch the order, usually you get different answers. Not always. Sometimes you end up with the same thing, but most of the time you get something different. So if I'm doing g of f, right, that equals g of f of x. All right, so now my f of x function is going to be the input into my g function. All right, so that means g of the square root of x. Right, f of x equals the square root of x. So in place of this f of x here, I put the square root of x. And then I have g of that. And then I plug this into my g function. Well, the g function says whatever I have in that parentheses, I do the square root of 2 minus whatever that thing in the parentheses is. Well, since I have a square root there, the g of the square root of x is going to be the square root of 2 minus whatever's in these parentheses, which is the square root of x. All right, so that's going to be my g of f function. All right, the f function here, remember the second one is the input into the first one. So I take the square root of x into this function, this g function, and wherever this x is, I put in its place the square root of x, right? This function here. All right, so it's the square root of 2 minus the square root of x, right? Composition of functions, I'm combining two functions together. One function is the input to the other. Wherever the x is, I put that entire function in its place. All right. And in this case now, the other one we were able to combine those two square roots together and make it the fourth root of x. We can't do that here because those square roots are separated by this 2 minus is kind of in between. Right? Remember, those rules that we did like before, like the 1/2 power raised to the 1/2 power, I can only do that if it's that 1/2 power raised to another. If I try to do this one with the 1/2 power, it would be 2 minus x to the 1/2, and then that whole thing raised to the 1/2 power. But since there's subtraction inside this parentheses here, I cannot distribute that exponent and make it like a 1/4 power, right? Remember, the rules of exponents say I can do that when what's inside the parentheses is multiplication or division. I can't do it when what's inside is addition or subtraction. And so what that means is that I cannot simplify this any further, right? So the g of f function is equal to the square root of 2 minus the square root of x. All right, that's what g of f is equal to, and there's no more simplifying you can do from there. All right, the next one here, f of f. Right, you can compose a function with itself, right? Just you take that function and just put it into itself, and you get a composition of a function with itself. It's a little weird, but there's no reason you can't do that. Right, so f of f means f of x. All right, so that f of x in the parentheses here, well, f of x is equal to the square root of x. So it's f of the square root of x. All right, and then I'm taking that square root of x and I'm plugging it into the f function again. So the f function says whatever's in the parentheses, I put underneath the square root. So it's the square root of whatever's in these parentheses, which is the square root of x. All right, so it's the square root of the square root of x, which, just like the one we saw up here, since those two square roots are like right next to each other and there's no addition or subtraction inside, I can just write that as x to the 1/4 power. Right? Or not x to the 1/4, I should write it as the 4th root of x. Those two are the same thing, right? If I convert this to x to the 1/2, and then that whole thing raised to the 1/2, the power to a power, I multiply, I get the 1/4, which is the 4th root of x. All right, so that is what f of f is equal to. When I combine, or I compose that f function with itself, I get the 4th root function, right? The square root of the square root is actually the 4th root. All right, so that's my f of f. And then the last one up here, g of g. All right, so now I'm going to compose the g function with itself. Right, so that means g of x, which means g of the square root of 2 minus x. All right, so that's this g of x here is equal to the square root of 2 minus x. Now I'm going to take that whole expression and plug it into the g function. So the g function says whatever I have in parentheses, I do the square root of 2 minus that thing, right? Whatever's in here, I put right there. Well, what's in here now is this other square root thing. So this is going to give me the square root of 2 minus, and then I put this in place of the x here. I'm putting this whole square root, the square root of 2 minus x. And that's my g of g function. Right? So g of g equals the square root of 2 minus the square root of 2 minus x. All right, so all of that underneath that one single square root. All right, so when you start doing compositions of functions, especially when you start getting radicals and roots and stuff like that, you can get some really weird looking functions. All right, the square root of 2 minus the square root of 2 minus x. All right, and once again with this one, just like with the one up there, part B, we cannot combine those together. Because of the subtraction in here, in between this square root and this square root, we cannot combine those together, so those will have to stay separate. All right, so that's doing compositions of functions. You can compose a function with itself. You just take whatever the second function listed is, you take that entire function, put it into the other function, wherever the x is, you take this function and put it in the place of that x. Right, so that's what you do every time you have to do a composition of functions. I'm going to pause the recording here and put up 1 or 2 more examples where we look at compositions of functions graphically and numerically, like with a table of values. You can kind of see how those work. All right, in this example here, we're going to look at evaluating a composition of functions given the graph of the two separate functions. Right, so here we have a graph of a g function in purple and a graph of an f function in black. And we're asked to find 2 things, f of g of 0 and g of f of 2. Right, so when you're trying to evaluate a composition of functions like this, you kind of have to work your way backwards. Right, f of g of 0, remember, the first one that we use is actually the second one that's listed here. So I take my input value 0, and I actually plug that into the g function first. Or maybe a better way to do this would be to rewrite this. F of g of 0 means f of g of 0. right? So I kind of have to do this as a two-step process. So g of 0, well, what is g of 0? Well, when x equals 0, g is up here, which is equal to 3. Right, so this equals f of 3. Right, so again, this number here, I plug that into the function that's next to the number. So I plug the 0 into the g function first. You know, the input value is my x, so when x equals 0, g is up here at 3, and so I get f of 3. And now the output from that g function, which is the 3, right, g of 0 gives me 3, that becomes the input to the f function. So now I want to find f of 3. So now I go back to my graph. The f function is the black one here. I go to x equals 3, and the output, or the y coordinate when x equals 3, is 0. All right, so f of 3 equals 0. So it turns out that f of g of 0 equals 0. All right, I do g of 0 first, I get 3. Then I do f of 3, and I get 0 again. All right, so that's f of g of 0. All right, so you have to do, plug the number into the g function first, take that output, plug that into the f function, get the output of that. That's your answer. All right, for the second one here, g of f of 2. All right, well here I have first the f of 2, and then I'm going to take that output and plug it into the g function. All right, so f of 2. Right, so when x is equal to 2, my f function is down here at a y coordinate of -2. Right, so this is equal to g of -2. Right, I do like the inside function first, and then I do the outside function, right? The f of 2 is on the inside, the g is on the outside of the parentheses. I do what's inside the parentheses first. I evaluate f of 2 when x equals 2 on the f function, y equals -2. And now I need to find g of -2. So now -2 becomes the x coordinate that I look for, and the g function is the purple one, so I go to -2, and at -2 my g function has a y coordinate of +1. So g of f of 2 equals 1. All right, f of 2 gives me -2, g of -2 gives me 1. And that's how we do a composition, or evaluating a composition of functions given a graph of the two separate functions. Right, you always have to do basically 2 steps there. Whatever the inside function is, evaluate that, look for the x coordinate, find the y coordinate on that graph that goes with it, and then whatever that answer is becomes the x coordinate that you look for on the other graph. All right, so I'm going to pause this one more time and do another example where we look at a composition of functions given just tables of values and how we can evaluate that. All right, last example that we'll do here, evaluating some compositions of functions given just a table of values for the functions, right? So we don't have the function rules, we don't have the equations, we just have a list of numbers for the x, the input values, and then the f and the g functions. Right, so if I want to find g of f of 2, remember what that means is g of parentheses f of 2. All right, so I need to do what's inside the parentheses first. So I have to evaluate f of 2 and then find g of that. Well, to evaluate that on a table of values, if I want to find f of 2, I go to where x equals 2, and then when x equals 2, my f function is 3. All right, so f of 2 equals 3. So this is going to give me g of 3. All right, so I go, again, the inside function first. 2 is my x value, so I go to 2. And then when x equals 2, my f function equals 3. So f of 2, it gives me 3. And then I find g of 3. So now 3 is my x value. I go to 3, and then I go down to my g function, which is 6. All right, so g of f of 2 equals 6. Right, again, it's that 2-step process. I plug the 2 into the f function first. I get 3. That becomes the input to the g function. When x equals 3, g equals 6. All right, the next one here, f of g of 6. All right, so now I have the g of 6 inside the parentheses, so I start with that. When x equals 6, my g function equals 4. So this gives me f of 4. Right? So I evaluate that inside function first, the one inside the parentheses. 6 is my x value. When x is 6, g is 4. And now I need to find f of 4. So now I go to where x equals 4. And when x equals 4, my f function equals 1. So f of g of 6 gives me 1. Right, again, 2 steps. First I plug the 6 into the g function, gives me 4. I plug the 4 into the f function, that gives me my final result. All right, so that's a few examples of a few different types of problems that you might see doing a composition of functions. Remember, it's 2 functions put together, or it's one put after the other one.